Very good morning, good afternoon, and welcome my students for the project management course. This is the 23rd lecture, and I am sure you have understood the problem for the Pert, which is project evaluation review technique, that considering the job timings are given, how you can find out the overall critical path and then take decisions accordingly. Even though I did mention that crashing the jobs depending on resource constraints, all these things can also be done considering costs are linear in nature. So, linear cost would basically mean trying to reduce the number of days would have a linear increase in the cost structure. Any non-linear increase would basically mean that trying to find out which job to basically take first to crash in very complicated project sometimes becomes very difficult. So, if we continue with the last example where we left at the end of 22nd lecture. So, once you find out, use the concept of forward pass, backward pass concepts, and you find out the total slack, the free slack. So, at last we have, as per the problem, the slacks available for the activities job task are as follows. A does not have any. So, obviously, it means 0, it has to be on the critical path. B has 8, C, D, E, all of them have 0, which means as you actually can understand and you can rightly point out, the critical path would consist of the job, the activities which are in sequence as A, C, D, E. So, this 8 means the number of slacks or the cushions which I have been mentioning time and again would be 8 number of days for job B, such that it can be slided or moved or broken down accordingly, such that it does not exceed that 8-day cushion which you have. In case if it increases, obviously it will have an effect on the critical job later on. Point number 1. Point number 2 is that if you are able to basically crash this job, say for example, in job B, then with and also you are in a position to crash job C also. So, job B crashing may reduce the cost, but would not basically have any effect on the critical path. Point 1. Point number 2, if you basically concentrate only on C, the overall positive effect in the sense that you are able to decrease the total cost for the whole project would be much more substantial if you take care of the critical paths, because that would be difficult, because crashing one would be of one of the critical activities or the task along the critical path may be difficult to find out, may be difficult to handle, but if you are able to do that, then the end of the day the result is that the overall crashing of the total cost is much more substantial and it has a much more positive effect on the overall project. So, thus, okay, before I just read these points in this 280th slide, the concepts which based on which we find out the critical path for the Pert method would be exactly the same for the CPM method, which is critical path method. The only difference, if you remember, that Pert has optimist time, pessimist time and the most likely time. Based on that we find out T, and based on that we do the calculations. Point number 1. Point number 2 is that there would be a variance concept also coming from the Pert, because if it has a distribution, the random variable based on which the distribution time varies, then you will have the variance, and variance can be utilized in order to find out that what is the overall dispersion or overall shifting of the percentage of the job being completed when you are considering the Pert method. For the CPM, you would not have those luxuries in the sense the randomness is not there with respect to time, but obviously it will also mean that finding out what is the probability that you are able to finish 90% of the job, or based on the deadline which you have, what is the percentage of the job still left, may not be possible under the CPM method. So, with that I will continue this slide. The expected number of days required to finish a project is the sum of the number of days for each and every activity which is there on the critical path. Remember, the time required for each activity job task must be respected to the expected time, considering that is a Pert method, and for the CPM method is the time which is as given. The critical path length is also calculated using the respective expected time of each activity job. Now, if I want to find out the variance which I just mentioned, because variance would be required to find out that what is the percentage of delay, or if you think that the deadline is given, what is the percentage of the job still to be done, then we need the variance or the standard deviation for each and every path or activity. Now, for each and every path and activity of the job which constitutes the whole project, you will have the optimist time, the pessimist time and the most likely time. Based on that, you can find out the variance, which is as given in the third bullet point. The variance of an activity job task is given by Tp minus T0, which is the pessimist minus the optimist, divided by 6 whole square. This is basically, you can use the distribution as given and then calculate the variance. Remember, for finding out the variances of the total project. So, this point is important, I am going to again read it. Remember, for finding out the variance of the total project, we simply add the variances of the activities, do not add the standard deviation, we add the variances of the activities and not the standard deviation. The important assumption which helps us to add the variances is that the activities and the jobs are independent of each other. This is point number 1 for this third bullet point. Another point which will be useful when we find out to find the relationship that for these queries, that what percentage of the job is finished, we would not be using the distribution for the Pert each and every individual activities, because if you remember in one of the classes, either in the 22nd or the 21st, I did mention the concept of central limit theorem, which means that considering the distribution being either gamma or beta or whatever it is, as the number of observations basically increases, you are tempted to take, and with theoretical background for that, that the normal distribution comes into play with the respective mean and the variance being for the original distribution based on which you are working. So, we will see that within 1 or 2 minutes. So, again the important assumption being that the activities are independent of each other, hence you add up the variances, not the standard deviation. So, consider the graph is again exactly the same thing, only thing which has been added here in this case is these parts, numbers. So, these are very explicitly, it should be mentioned in the problem whether they are the variances or the standard deviation. So, if they are the variances, then it would mean that if I want to find out the variance of the critical path, this one, this one, this one and this one, which is 1, 2, 2, 3, 3, 4 and 4, 5, you will add 4 plus 1.5 plus 2 plus 3. So, the overall variance for the critical path would be, this V is the variance and Cp is the critical path, would be 4 plus 1.5 plus 2 plus 3. And if I want to find out the standard deviation, which is SD is the standard deviation, then Cp is again the critical path. So, this critical path actually is, let me write it down, critical path is equivalently 1, 2, 3, 4, 5. So, the standard deviation will be square root of 4 plus 1.5 plus 2 plus 3, and you can find it out accordingly. In case if 4, 1.5, 2 and 3 are the standard deviation, then you have to basically square them up and find out the overall variance, and again then find out the square root to find out the standard deviation of the critical path. Now, what is important to note, which I mentioned in the 280th slide, is that whatever the distribution is, when you want to find out the overall completion or percentage of completion, we will use the central limit theorem. So, if you are giving the respective expected time and the standard deviation for the activities task, can we know the critical path for certainty? The answer is no. Reason being that as you have the standard deviation means the dispersion. So, if I have this expected time and not the standard deviation in case it is not given, it means that each and every activity would be finishing by that exact expected time or the time for completion of the task. But the moment you have the variations or the variance or the standard deviation, it means that there is a probability of trying to finish up that particular activity or job based on the expected time. So, when we want to find out the exact time for the whole project, you are trying to basically find out by adding up the sums of the expected value. But in that case, the variance, as just mentioned in the 281st slide, that how you calculate the overall variance for the overall project, then it would mean that there is some variance or some amount of dispersion, that some probability of the overall job with respect to the time would be finished within that certain number of days which is there. So, expected would basically mean on an average, if you continue doing that particular job time after time, the average time taken to finish that project or that particular set of activities would be given by the expected time. But if there is a delay, so this delay should be taken into consideration, considering the fact that variance has come into the picture. If we are lucky, then a simple calculation, as we have done in the earlier, can solve the problem to provide us with the critical path and the respective critical activities, jobs and the task. In case we cannot, then we use simulation to find out that what is the critical path and what is the average value of the critical path and what is the variance of the critical path. So, simulation concepts can be utilized in order to find out that which jobs and activities would be appearing the maximum number of times as you do the simulation, and then you find out that what is the average time based on which the overall project would be finished, such that that is the expected time, and then we find out the variances accordingly. So, in this problem, let us consider the activities are given on the first column, which is 1 2 1 3 2 4 3 4 4 5 3 5. The expected time is given. So, this expect time considers that for the Pert method, the optimist time, the pessimist time, the most likely time were given. Based on those informations being given, you find out the second column, which is the expected time. So, those are there. Then based on the pessimist time and the optimist time, we find out the standard deviation using this formula. So, your actual formula, if you remember, I am again repeating it. The expected time is found out using the pessimist time 4 times the most likely time plus the optimist time, all these things should be divided by 6. And in case if I want to find out the variances, variance would basically be the pessimist time minus the optimist time, and then you basically square it up with divided by 0. Let me go back to the formulas. So, divided by 6 whole square. So, use these formulas to find out this and find out this. So, these are found out given whatever informations which are there, which let me highlight is TP, TM, TO. So, the longest path, I will just remove this on the left hand side, it is easier. So, the longest path is 135 and the expected time for or the critical path is given by adding up the sums, which is 12 plus 16 which is 28, and the corresponding variance for that path, which is 135, would be given by adding the variances. So, what are the variances? It is 9 and 16, add them up, it becomes 25. This implies that the job may take anything between, now it is important to note what I am saying. So, average time is 28, variance is 25, deviation is 5. So, if I want to find out that the distribution whatever it is will take the central limit theorem to be true, now this 5 is one standard deviation. So, 28, which is the average value in the in between, which is the normal distribution, and this is 28. If I go on to the right, that means on to my right 5 units, it means that one standard deviation plus the work would basically be finished with the number of days being 28 plus 5, which is 33. So, this would be basically 33 and this value is 28. And if I go, so let me use different colors to highlight. So, this value, this one is 28 minus 5 is 23. Now, if you look at this distribution, if you follow the simple concept of standard deviation, it would mean that within the number of days between 23 to 33, you are assured that you will basically be able to cover in a very theoretical sense. I am just first mentioning the theoretical concept, that the overall area of coverage is about 2 standard deviation onto the right and the left. So, the overall coverage is, let me go into the just the values, it may not be exact, it is about 67. So, which means that plus minus 5, the overall concept of the number of days is coming out to be 23 and 33, such that the overall coverage of the area is 67%. Now, if I go one step further, if I go plus 2 sigma and minus 2 sigma, which would be here and here. So, the overall coverage now is 4 sigma. So, this value would be 28 plus 5 which is 10, which is 38, and this value would be 28 minus 5 which is 10 is 18. So, this 18 to 38 basically would mean that with plus 4 sigma, that is plus 2 sigma and minus 2 sigma, I am able to finish the job within that stipulated time. So, again continuing what is written here, this implies that the job may take anything between 28 to 33 days. The next longest path has a length of 23. If you go back to the figure which is in 283 number of slide. So, it means that the next longest path after the critical path has a length of 23 and the corresponding variance is 9. Now, here we should pause and try to understand. If it is 23, then plus minus 1 sigma would become 23 plus 9, which is 32, and 23 minus 9 would basically mean it is 14, which implies that the maximum and the minimum time required along this path would be, my mistake, I am sorry, the variance is 9. So, standard deviation would be calculated by square root of 9, my apologies. So, it will be 23 plus 3 is 26 and 23 minus 3 is 20. So, which means that what if due to some external circumstances the standard deviation of the path 1, 2, 2, 4 and 4, 5, which is there in the next longest path, which is 1, 2, 4, 5 are given as 4, 8 and 3, then the new sum the variance for this path would basically now become 4 square, which is 16, 8 square is 64, 3 square is 9. So, it is basically 89, in which case the maximum time required along this path would be correspondingly found out as 32.43, which is 33. So, I am just trying to bring some information into this concept. So, if you see this 33 value and this 33 value. So, this 33 value, the first one which is here where I am now trying to point my the pointer, this 33 is with respect to the critical path and this 33 is with respect to the other path which is not critical. Now, where does the problem arise if you have the Pert concept actually take into consideration the practical applications which are there, which would mean that now we will see that the critical path is or may not be the actual critical path which you have found out using the concept of backward pass method and the forward pass method. The next longest path is coming into the picture because the overall standard deviations of the set of activities is very high, or the number of such standard deviations are much more in number because the number of such activities and jobs are much higher in number than the critical path. So, when you basically square up the standard deviation, find out the variance for the not critical path, then adding up plus minus 1 sigma onto the average time for the not the critical path method would basically mean that it may become, if dispersion comes into the play in the practical sense and if there are delays, then that set of activities which is not along the critical path may become important, such that you have to pay more attention to those activities which are now basically going to create problem in the sense that any reduction in the number of days or any exceeding the number of days for those non-critical activities would basically have a huge amount of consequence in trying to understand that what is the critical path and what is the overall time required for that particular project. So, this forward scheduling and backward scheduling I am just bringing into the picture. The reason being that when you are trying to do the forward scheduling and the backward scheduling, I did mention, even though I did it may be a repetition. If you remember, we mentioned the concept of the CPM and the Pert is based on the fact that once one job ends, then only the next can start, which is the end to finish, end to start concept. So, ES concept, but there are three other concepts also, which is end to end, then it starts to start, and one is start to end. So, if you have those three concepts being brought into the picture, then the overall calculation of trying to find out which is the overall algorithm which you had for trying to find out the forward pass method and the backward pass method and trying to find out the critical path and the slacks and the free or the total slacks, whatever it is, may turn out to be different from what we have seen. Point number 1. Point number 2 is that as you try to utilize those concepts in trying to calculate what is the critical path, then using the central limit theorem, as we just saw in the example which in the 284th slide, would have a consequence such that the non-critical path becomes important for you to consider. Considering variance is very important, and add on to that, if you use the concept of not the end to start concept, then the slacks and the total slacks which you have calculated using that end to start concept may not be true. Hence, trying to find out that what is the critical path, what is the delay, what is the dispersion would give you a totally different picture if your overall add-ons based on which you are trying to do the slacks and the total slacks are not end to start, but the combination of the 4, then doing a detailed analysis may become very cumbersome. That means, it is a difficult problem to solve, and you have to do whole lot of calculation using some simulation technique like SLAM, or trying to use any optimization tools, or trying to utilize any different type of softwares like MATLAB, Cplex. So, solving such problems using Excel may be difficult. So, you will try to use some softwares like that. So, in those cases you have to be very careful that what are the actual concepts which are being utilized to find out the slacks, the total slacks and the critical path, then what is the variance, what is the standard deviation, whether you are able to use the central limit theorem to calculate all these things would become necessary. And then next on you will try to, sorry, my apologies. So, next you will be able to go into the discussions that after you are able to solve that, then your question would be that what if I try to crash one of the jobs which are not in the critical path, which are in the critical path, whether the cost structure is linear, non-linear. So, those things basically pile up in such a way that trying to basically solve a problem in its whole gambit, where the problem has different nuances, may become very interesting, but also difficult to solve. So, if you remember, I did mention about the central limit theorem and how whatever the distribution is, your actual dispersion based on which you will try to find out that what is the percentage of the job which is finished, you are trying to utilize the concept of the normal distribution. So, this is how the normal distribution would look like. This value which you have, I am trying to point it out, this is T for the whole project or for the critical path, and this is basically the sum. So, I am using T1, T2, T3 till say for example Tn, where T1, T2, T3 till Tn are the expected time taken to finish activity 1, 2, 3, 4. Based on the fact for T1 you have the optimist, the pessimist and the mean and the mean time. Similarly, for T2 you have the optimist, pessimist and the mean time, and correspondingly to the last job in that critical path which is Tn, it has got pessimist, optimist and the mean time. Then obviously, you will have the standard deviation. So, the standard deviation would basically be the square root of the sums of V1 till Vn. So, this is V. So, this is basically V1 till Vn, where V1 is the variance for the first job which has got the average time T1. Similarly, the last one Vn is the variance for the last job in that critical path for which the average time is Tn. Find out standard deviation. So, this standard deviation is what is here. So, if you consider again the overall area, it is approximately 67%, and based on that you will do the calculation. If it is plus and minus, the overall area would be correspondingly found out using the standard normal table. So, standard normal table would have all the values. So, in maximum of the projects we are first given the due date. So, now we are trying to basically come into the concept of the due date. So, in the last the slide, which is the 286 slide, you saw that how the normal distribution was done, how where T was, which is the average time and expected time for the whole project considering the critical paths. Then you found out the standard deviations and added the standard deviation onto the right and the left, considering 2 standard deviations over overall coverage of area. So, in maximum the projects we are given first given the due date. So, due date is now coming into the picture. So, now the due date which is given may be more than T, less than T. So, you have to basically find out that how the due date will affect. Now, your immediate question would be that if due date is on to the left of T, obviously it should be very fine, but the problem is that if there is dispersion, so there would be some variance in trying to finish off any of a set of activities which is there on the critical path or which are not there on the critical path. So, if they overshoot due to some reason or the other, then obviously it would mean that the time taken on an average would be much more. So, in that case the effect on trying to finish off the job would basically have a devastating consequence on the due date and the overall cost structure. In case if say for example, the due date is on to the right, then it would mean that on an average that if you are able to finish, if there is a less or more amount of variance in the total overall set of activities, then also it may have a negative impact. So, in maximum of the projects we are first given the due date, which we will denote by D, or the completion date, that is at which date we have to complete the job, and then deciding what is the project, we decide the activities, job, task, and find out the critical path whether we can finish the project within that due date. In case we assume the expected time, the variance of each and every activity, which is T and Vt, the variance T, we find out what proportions or portions of the project would be finished within the date, due date, and the completion date. So, now we will try to basically bring into the concept of the critical index, which I will explain in the later class, which is the 24th one, because this 23rd is almost at the fag end to I need to finish it, but I will just give a detailed explanation of critical index in a qualitative sense and then carry it on in the 24th class. So, criticality index would also be required to found out for the jobs. I can say for example, we run a simulation study. If you remember, we said that the more you basically simulate, you will able to find out what are the jobs which are coming out maximum number of times in the critical path. Based on that, we say that they are on the critical path and they are the critical activities. So, we run the simulation for say for example, 100,000 times, which is 1 lakh number of times, and if an activity job is on the critical path 30,000 number of times, we say its critical index is 30,000 by 1 lakh. So, it will be 30%, which means that job would come up in the critical path 30 number of times. So, basically out of a simulation of say for example 100. So, if we have the critical index of many of the paths, then what we will do is they simply will rank them from the highest critical index to the lowest one and choose those paths which actually make a sense to complete the job, because it may so happen that if we add up the top most critical index path, they may not make the overall job complete. So, it may happen that I will just spend 1 or 2 minutes. So, say for example, the critical index of this path, this path, this path and this path, and if I consider the top 5, they are coming into the picture. So, this added up, you will see they are actually some activities, logical activities, but they do not complete the project. That means, they are not as per the concept of the critical set of activities which makes the critical path, because you have to start at 1 and finish at 6. So, if this 4 6 or 5 6 is not there, so obviously it does not make any sense to consider them as important for the critical index concept. So, with this I will end the 23rd lecture, and in the 24th lecture I will start discussing something about the critical index and then carry forward the concept which I have been mentioning about the critical path concept, the variance, and how they can be brought considering the central limit theorem to be true. Thank you very much and have a nice day.